A Lambda function with administrator access was exploited through a prototype pollution vulnerability in an NPM package. In 4 minutes, an attacker created 3 identity and access management users, launched 50 GPU instances for crypto mining, and downloaded 2 TB of customer data, resulting in a $47,000 bill. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Amazon Web Services Identity and Access Management Identity Access. Amazon Web Services Identity and Access Management is the service that defines identities and attaches policies to grant or deny actions on resources. Every API call is evaluated against all applicable policies. If any policy explicitly denies the action, the call fails. Otherwise, if any policy allows it, the call succeeds. This is the least privilege enforcement point, evaluated in real time for every request. The most common confusion comes from mixing up users, groups, and roles. Users have permanent access keys. Groups are just containers for users. Roles are temporary identities for machines. They have no static credentials. When something assumes a role, Amazon Web Services Security Token Service issues temporary credentials that expire automatically between 15 minutes and 12 hours. Every role has 2 separate policies. The trust policy answers, who is allowed to assume this role? The permission policy answers, what actions can this identity perform? If the trust policy doesn't list the service, no amount of permissions will help. Always check the trust policy first when debugging access issues. Here's a real CloudFormation template that creates an identity and access management role for Elastic Compute Cloud with scoped simple storage service read access. It defines the trust policy, the permission policy, and the instance profile wrapper that Elastic Compute Cloud needs. Let's look at the code. This CloudFormation template creates an identity and access management role for Elastic Compute Cloud with read-only access to a single simple storage service bucket. Notice the trust policy allows only the Elastic Compute Cloud service to assume the role. The permission policy grants only simple storage service, list bucket and simple storage service get object on a specific bucket and prefix. Also note the instance profile resource. Elastic Compute Cloud cannot use a role directly. It needs this wrapper. Every identity and access management policy is a JSON document. The core is the statement array. Each statement must have effect, action, and resource. Condition keys like Amazon Web Services, requested region are your secret weapon for narrowing permissions. Remember, principal is only used in resource-based policies and trust policies, not in identity-based policies. Here's a policy with 2 statements. The first allows read and write on a DynamoDB table. The second explicitly denies deleting that table. Because deny always overrides allow, the role cannot delete the table even though other actions are permitted. This is a common pattern to add safety rails. Least privilege means granting only the exact permissions needed. The practical path is to run your application in staging with CloudTrail, then use Identity and Access Management Access Analyzer to generate a type policy from actual API calls. This takes 10 minutes and produces a policy you can trust. Combine this with SCPs at the organization level and Amazon Web Services config rules for continuous monitoring. This script uses Identity and Access Management Access Analyzer to generate a least privilege policy from CloudTrail logs. It starts a policy generation job, polls until completion, and saves the generated policy to a file. The output contains only the API calls the application actually made, not guesses. This is the same issue we highlighted at the start. Here's exactly why that happened. The team attached administrator access to an Elastic Compute Cloud role for convenience. An attacker found a vulnerability in the web app running on that instance, used the metadata service to get the role's credentials, assumed the role, and launched 100 GPU instances for cryptocurrency mining. In 3 hours, the bill hit $47,000. The fix is to never attach administrator access to any compute role. Instead, use service-specific policies and always set a permissions boundary to cap maximum permissions. Deploy Amazon Web Services config rule, identity, and access management policy no statements with admin access to alert within minutes if a role receives admin permissions. This prevents the exact pattern from the incident. The biggest mistake is using administrator access on Lambda or Elastic Compute Cloud roles just to make it work. A single compromised function gets full account access in seconds. This is exactly what caused the $47K incident. An attacker exploited a vulnerable web app, assumed the role with administrator access, and launched GPU instances for crypto mining. You cannot attach an identity and access management role directly to an Elastic Compute Cloud instance. You must wrap it in an instance profile first. In CloudFormation, you need both the role and the instance profile resources. Always reference the instance profile Amazon resource name in your launch template, never the role Amazon resource name. Every statement must have effect, action, and resource. Forgetting the resource field causes a policy validation error when you try to attach it. Always include resource, even if it's a wildcard for certain actions. The article mentions security token service tokens are valid for 15 minutes to 12 hours. However, as of 2024, the max session duration for roles assumed via the console or CLI defaults to 1 hour and can be set up to 12 hours. For roles assumed by Amazon Web Services, e.g., Elastic Compute Cloud, the session duration is typically fixed at 6 hours. Always check the service-specific documentation for exact limits. The article mentions the Identity and Access Management Policy Simulator, but doesn't show a concrete example. Here's how to use it to identify which statement caused an access denied for a specific action. The article states SCPs can deny root actions, but this only applies to accounts within Amazon Web Services organizations. For standalone accounts, not part of an organization, SCPs are not available, and the root user retains full, unrestricted access. In such cases, rely on MFA, access key removal, and CloudTrail monitoring as the primary defenses. When debugging access issues, start with the trust policy. Then use the Identity and Access Management Policy Simulator to reproduce the deny in a controlled environment. CloudTrail logs show the exact event and error. The Simulate Principal policy command tells you which statement caused the deny without making the actual API call. Let's run through some common interview questions. What is the difference between a trust policy and a permission policy? Trust policy controls who can assume the role. Permission policy controls what actions the role can perform. How does least privilege work in practice? Use Identity and Access Management Access Analyzer to generate policies from CloudTrail data, apply SCPs at the organization level, and monitor with Amazon Web Services config rules. What is the confused deputy problem, and how do you prevent it? A third party could trick your role. Use Externalid or Amazon Web Services. Source ARN conditions in the trust policy. And a few frequently asked questions. Can I use a role for a human user? Yes, via Security Token Service Assume role, but use Identity and Access Management Identity Center for humans instead. What happens if I lose the root MFA device? Use the recovery code stored in a secure location. Without it, you'll need to contact Amazon Web Services support. How do I grant cross-account access? Create a role in the target account with a trust policy allowing the source account's principal, and ensure the source principal has security token service, assume role permission. To recap, use Identity and Access Management roles for all machine identities and Identity and Access Management Identity Center for humans. Remember that trust policy and permission policy are completely separate. Both must be correct. Never attach administrator access to any compute role. Use Identity and Access Management Access Analyzer to generate least privilege policies from actual usage data. This combination prevents the $47K mistake and keeps your account secure. Ready to go deeper? Up next, Amazon Web Services Relational Database Service and DynamoDB, then Amazon Web Services Lambda and Serverless, then Amazon Web Services Fargate. Serverless containers on Elastic Container Service and Elastic Kubernetes Service. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.